Imagine the most high-pressure place in any hospital, the intensive care unit. In the ICU, doctors are in a constant race against time, where every single second counts. But what if a new kind of AI could see a crisis coming, not just minutes ahead, but hours in advance? Today, we're going to break down a tool that's being developed to give doctors something absolutely priceless, a head start. You see, in critical care, a patient's condition can just flip in the blink of an eye. Doctors and nurses are on high alert, 24/7, watching, looking for those tiny, subtle signs that things are about to go wrong. The real challenge, though, it isn't just spotting a crisis as it happens, it's seeing it hours before it even begins. And the stakes here? They couldn't be higher. We're talking about a condition called medical shock. And when a patient goes into this state, the mortality rate is just staggering. We're looking at 30 to 40%. It's a race against the clock where the odds are incredibly tough. Okay, but what if you could completely change the rules of that race? What if an AI could look at all of a patient's data and raise a red flag, giving doctors a full 24-hour warning before the crisis actually hits? That incredible idea is exactly what we're going to dive into. So before we get to the AI itself, we really need to understand the enemy it's designed to fight. What exactly is medical shock, and why is it so unbelievably dangerous? At its very core, shock is a circulatory collapse. Think of it like this. The body's entire delivery system for oxygen and nutrients just grinds to a halt. The tissues and organs are literally starved. And if it isn't treated immediately and aggressively, that starvation leads to organ damage and eventually total organ failure. So what kicks this off? Well, it can be a few critical things. Maybe a massive loss of fluid from a serious injury, or the heart just failing to pump blood like it should after a heart attack. Or it could be a widespread infection, something called sepsis, that causes blood vessels to start leaking all over the body. Now, for decades, doctors have used a pretty simple but really effective tool to gauge this risk. It's called the shock index. All you do is take the patient's heart rate and divide it by their main blood pressure number. If that result is 0.7 or higher, that's a huge warning sign. And this specific number, this is the target the AI is being trained to see coming.
All right, this is where things get really interesting. The AI system that's designed to be that early warning is called shock modes.
The mission for the researchers behind shock modes was, well, incredibly ambitious, but it was also crystal clear. Could they build an AI that could look at all the patient data available and reliably predict if that patient's shock index was going to cross that dangerous 0.7 line sometime in the next 24 hours? So, how in the world do you build a digital crystal ball this powerful? Well, the secret isn't just in one type of clue. It's all about teaching the AI to think like a seasoned detective, pulling together multiple streams of information. Think about how a great detective works. They look at two kinds of evidence, right? On one hand, you've got the numbers, the hard, cold, objective data coming off the machines, things like heart rate and blood pressure. But just as important is the narrative, the rich story found in the doctor's own notes, detailing the patient's history and the treatment plan. This AI was built to analyze both. To learn these skills, you need a ton of data. The system was trained on a massive real-world data set called Mimic-3. It crunched the numbers from over 17,000 ICU stays, learning to spot all the hidden connections between 4 key vital signs and the clinical notes for every single one of those patients. Okay, so we have the mission and we have the data. So how do you actually train this digital detective to spot patterns that are pretty much invisible to the human eye? Well, the process basically follows 4 key stages. First up, you collect all that raw data, the vitals and the notes. But raw data is messy, so the next absolutely crucial step is to extract the features. That means finding the important signals hidden in that mountain of information. Then, and only then, can you train the models to make predictions. And finally, of course, you have to test and validate everything rigorously to make sure it's accurate and reliable. This feature extraction step? Okay, this is where the real magic is. For the vital signs, the AI isn't just looking at the number right now. It's analyzing the patterns over time. It's kind of like listening for a hidden rhythm in a patient's heart rate, or noticing tiny changes in breathing that a person might miss. And for the notes, it uses natural language processing to actually read and understand the doctor's language, picking out keywords for drugs, like heparin, and grasping the full story of the patient's condition. So, the AI can predict a crisis. That's amazing. But in medicine, a correct prediction just isn't enough. For a doctor to actually act on it, they need something just as important. They need to trust it. They have to understand why the AI is raising an alarm in the first place. And this is really the million-dollar question for AI in any high-stakes field. An AI that just spits out an answer, this patient is high risk, with no reasoning? That's a black box. And let's be honest, it's really hard for a doctor to bet their judgment and a patient's life on a black box. To solve this, the researchers used this brilliant technique called a SHAP. The best way to think about it is as a translator for the AI. It takes the AI's complex decision and basically forces it to show its work, revealing exactly which vital sign or which word in the notes pushed the risk score up or down. In short, it cracks open the black box. And what's so cool about SHAPE is that it gives two incredibly valuable levels of insight. You get a local explanation, which tells the doctor why the alarm was raised for this specific patient, right here, right now. But you also get a global explanation, which shows the big picture patterns the AI has learned, which factors it thinks are the most predictive of shock across thousands of patients. This builds trust for one patient and for the whole system. And that brings us to the real heart of this whole thing, the true breakthrough. It isn't just about creating an AI that can predict a crisis. It's about building one that can explain its reasoning. That combination of prediction and explanation, that's the key to building trust and turning AI into a true partner for doctors in the ICU. This incredible technology for predicting shock is really just the beginning. It leaves us with a fascinating question to think about. If we can give doctors a 24-hour head start on this one crisis, what other conditions, from kidney failure to cardiac arrest, could be next on the AI's predictive horizon? The future of proactive medicine might be a lot closer than we think.